Welcome, Prassad.
Thanks, Ken. Thanks. Thank you. Yeah, thanks for the introduction, Ken. My name is Prassad, and I teach. I'm in the Herberger Institute for Design and the Arts at ASU. I'll talk about that in just a bit. But I teach product design and development, and we think of design in these pretty large terms. And the photograph and the quote is from Max Bill, who was the first sort of president or rector of the Ulm School of Design in Germany. Quite an influential school in terms of design education, and tons of design programs across the world, from India, where I did my design studies, to schools in Europe, of course, in Asia, in the US, are modeled after what happened at the Ulm School. So it is a good way to talk about how, or to understand how the influence of design is pretty broad. You can start from the smallest object, which an industrial designer might work on, to largest cities, which urban designers, planners, architects might work on. So like I said, I teach in the Herberger Institute for Design and the Arts here at ASU. I'm in the School of Design Innovation, which has industrial design, interior design, and graphic design. But across the institute, we have everything from the School of Music, School of Art, architecture, landscape architecture, etc. And that's kind of the home that I reside in at ASU. But I wanted to start by talking quickly about the design process. This is from Make magazine. Someone mentioned DIY earlier on. But it's a pretty standard design process. You start by identifying a problem, brainstorm, you come up with an idea, a solution, you build, you test, you go through that cycle again, and finally you share your solution in this case, because it's Make magazine and they want to share as much information as possible so others can learn from what you learned in this process of designing things. Wanted to show another diagram, but this is from Ray and Charles Eames from the 1950s, who did a ton of furniture that actually Herman Miller still sells. In terms of timeless design, there's some of the furniture that these guys designed is really incredible. But Charles Eames talked about the design process, and he has these 4 different amorphous areas. And he talks about the first one, that the grayed out section. That this area represents the interest and concern of the design office. That's number 1. And the more square-like, step-like section, which is the area of the genuine interest of the client. That's number 2. Number 3, these are concerns of society as a whole. This is the kind of larger bean-like shape, and I would include society and environment in this case. And then number 4 is the central part in the center. That's where your work should exist, because you want to try and work with all these stakeholders who are involved in this process. And then he puts a couple of notes. One of the notes says that these shapes are constantly changing. These are not constant shapes. These are not static shapes. They are constantly changing. Problems keep changing. Contexts keep changing. So keep that in mind as you go through the design process. And there's some of the things that we talk about with students in the design program. So I teach product design and development. And one of the things we try to talk to the students about is the notion that very often the things that we design have very short lives. And they end up in landfills. And we have to try and see if we can increase durability, increase biodegradability, all the things that we have talked about today. How do you increase that how do you include that in the process of design? And these are images taken by Chris Jordan. I encourage all of you, if you haven't seen his photographs, he's a photographer from Seattle. His website is chrisjordan.com, and his stunning, shocking, frightening, and beautiful imagery. And he's doing more and more work in ecology, conservation, etc. So those are photographs of cell phones. We all know the lives of cell phones are decreasing dramatically. And in many cases, they have the same sort of function. We just like the newer one that's out there because it's sexier and cooler. And I think designers are to blame for much of what's happening. But some of his recent photographs are photographs of albatross. He's taken pictures of albatross chicks and also adult birds. And this is a quote from his website. So he took photographs on this island, a very remote island, 2,000 miles from the nearest continent. What he finds in these birds is what you see in this photograph. And these are, what you see is these lighters and a bunch of plastic parts. You may have heard of the Pacific Gyre off the coast, so between the US and Hawaii in the Pacific. There's this huge swirling mass of plastic. It's not really visible. You can't really take photographs of this, because in some cases, plastic that goes off of the coast sort of collects, and there's the water currents move in such a way that it sort of swirls around, and they say it's larger than the size of Texas, this mass of plastic, and it starts decomposing in sunlight and salt water, degrading, and it breaks down into smaller size chunks. And these birds, they see that as food. And so they're eating it and they're feeding it to their babies. So there are photographs of these albatross, and he has actually not moved the bird at all. None of this stuff has been placed. These are the contents of these birds' stomachs. And so we want to see these kinds of cute pictures of albatross, not what we saw earlier on. And what can we do as designers to make sure that the ecology, the environment, the nature, as we know it, can continue to live without having to eat garbage that we produce. So one of the goals of what I teach in our program is sustainable product design and development. I want to talk about this program that Ken mentioned earlier on called Innovation Space. We've been, this is the 6th year of the program. And this, it's a class, it's a 2-semester long class that's a capstone class for the engineers, for the design students. And we bring together teams of students in a studio environment. This is our studio at ASU. And actually, I have one of my students, Luke Morey, who's an intern for COFES. Luke went through this program last year, and he's around. He's doing some pretty interesting things now in our graduate program, along some of the lines of what I'm going to talk about today. But what we do is we bring together students and have them work in teams. Doc, you mentioned earlier today that there's very little cross-functional or transdisciplinary work happening at universities, and what we're trying to do is exactly that. So this program started as a joint agreement between the School of Engineering, the School of Design, and the School of Business. So I have 9 teams in my class. Each team has 4 students. One student is an industrial designer or a product designer. One student is a graphic designer. One student is an engineering student, and one is a business student. And then we work with industry. So this year I'm working with Herman Miller Corporation. They've sponsored my class for the last 4 years. Herman Miller has this division. They mostly do office furniture and residential furniture, but they have this section called Herman Miller for Healthcare. So supply carts for hospitals, chairs, the Aeron chair redesigned for nurses, things of that nature. So we are looking at how to improve the quality of healing environments, is what they call them, by having students work on these projects. And so they come up with product ideas, and I'll actually walk you through the process really quickly. Based upon this model of innovation that we follow, we call this integrated innovation. Very often what happens in design classes and design studios, industrial designers tend to think only of the artifact. We've talked quite a bit about the supply chain, we've talked about the entire system, we've talked about spoon to city, but it does not make sense for us in studios to just focus on the artifact, and that's actually our problem. We are thinking so much of the artifact, we don't think of all the other things that happen. So there are several stakeholders, and the reason we have these 4 students per team is to tackle something like this. Okay, so we have to design something that makes sense for the user, focus on human-centered innovation. The engineer on the team tries to make sure that it's technically feasible. The business student on the team says, okay, if we're designing this in conjunction with Herman Miller, it has to align with their strategic vision. And lastly, something that all 4 of them focus on in the team is to make sure that it's socially relevant and that it reduces impact on the environment. And this actually is a pretty simple model, but you can go into tremendous depth on each of those areas. They also start their process of research using these 4 questions, and they also, at the end, evaluate their ideas using these 4 questions. So it becomes a good way to generate ideas, but also a good way to evaluate the ideas that they've generated. So it's pretty simple, but can be pretty deep. So we start with pretty broad problems. For instance, one of the projects a couple of years ago was, how do you reduce hospital-acquired infections? As we all know, very often you go into a hospital, you leave with more germs than what you walked in with. There's several deaths that are recorded because of that. And some of these, the patient falls, hospital-acquired infections, often people go in and get the wrong arm amputated. Well, these are now being referred to as never events, things that should never happen in a hospital, and insurance is not going to cover those. So we looked at those. So we'll start out the class with a problem like that. How do you reduce patient falls? So the students go out into the field, they'll talk to nurses, they'll talk to doctors, they'll interview them, interview experts, come back, analyze all that information. And because we have 4 disciplines per team, the research that they do is in those 4 areas. So while the product designer might go out and do a benchmarking of all the products that exist in the market right now that help with patient falls, the business student might do a similar analysis but on the industry. The graphic designer might do a similar analysis but understand the brands. What are the brands that exist in this market space? And the engineer might look at what are some emerging technologies that can assist with patient falls. So that same problem gets analyzed from 4 different perspectives because we have a cross-functional team. We do tons of brainstorming. At this stage, we had these nurses and the users that we interviewed, or experts we talked to, come to class and brainstorm with the students so they can help them generate ideas. So this notion of participatory design, where you have your users come design with you, becomes a key part of how the students learn to design, how to think, how to go through the design process. It's not, I'm the designer, I know what to design, and I'll just give you this, and you better accept it and like it. It's not that. Let's bring the users in the process so we actually can design something that's valuable to the people. So lots of brainstorming, lots of ideation, and we start with a broad problem, come up with 300-400 post-it notes, pare those down, develop those concepts, and finally come up at the end of fall semester. Each team has 3 product ideas. Then we evaluate those over the break with the sponsors, and then in spring, and that's what we're working on right now. The class is not done yet. We'll be wrapping up May 10th. Each team picks up 1 idea, and then that's developed in much more detail. So again, the product designer will do a full design interface of the product. The business students write a business plan, like how would you take this to market if you had to. The graphic designer comes up with a name, a logo, advertising design, brochures, websites for the product, and the engineer builds a proof of concept prototype. And what's interesting about the class is that there's a lot peer-to-peer learning that happens. My design students don't really take that many courses in business. They may have one marketing 101 class. They may take maybe one course in engineering, but they don't really know how designers work with these other disciplines. So this becomes a really good way for them over a year to really understand this. And we get into the business students. We have supply chain management student, accountancy, management, marketing. So, and there's a mix of these students. From an engineering side, we have biomedical engineering, mechanical engineering, electrical engineering. So even intradisciplinary learning happens quite a bit. So there's a supply chain students who are teaching the designers about what does it mean to go from raw material to end of life. So there's a lot of peer-to-peer learning that happens as well. Some of the things that Terry talked about earlier on with sustainable minds, we employ that in the class as well. But what I'm going to talk about today is another technique that we've been trying out for the last couple of years. If you've seen the work of Janine Benyus, she wrote this book called Biomimicry, Innovation Inspired by Nature. About in late 90s, I think that's when the book came out. And she was one of the, she spoke at the US Green Building Council 2 years ago with E.O. Wilson. You've seen E.O. Wilson's work. He spoke, he actually won the TED Prize 2 years ago. Benyus also spoke at the TED conference about 3 years ago, I think. So we've developed a partnership with the Biomimicry Institute. And we've had Janine come to ASU. She did a big public lecture, came to class, and we've been working with them to see if we can look at nature and learn from nature, and to see if that can inspire some interesting, not only creative ideas, but more sustainable ideas to what we are designing in the classroom. So Terry mentioned earlier on with the Sustainable Minds, the software that she's developing. They use the eco-design strategy wheel, which the students use in class, looking at the complete life cycle from raw material to end of life. We also use another technique which also exists in Sustainable Minds. It's called the Ocala Impact Factor Assessment. So one of the advantages of having the engineer on the team is that the engineer is required to do a full bill of materials for what they've designed. And then you can calculate the environmental impacts of each of the components and parts based upon this system called the Ocala Impact Factor Assessment. And then the third technique we've been trying to use, which is more generative than analytical. So it can be used more in brainstorming rather than evaluating how sustainable or how much greener your product is compared to what exists in the market right now. This is more, let's come up with new ideas to do this. So we're trying to use this process that the Biomimicry Institute came up with a few years ago, which is you look at nature, you try to distill ideas from nature, like a Velcro idea, right? Translate that into potential product solution, evaluate it, and see if you really have a more sustainable idea because you've looked at what's happening in nature. And what Janine talks about is that you can't just have, say, people who are not trained in biology to go out and look for things out in the world and try to mimic it. We actually need to have biologists at the design table, and that's her term. So we were able to get some funding, and we've hired a PhD student in biology who actually is my TA for the class. So he does presentations on, he's actually a social insect researcher, does fascinating research on ant colonies. But he comes to class and talks about how do you really look at nature in interesting new ways, in functional ways, and learn from nature. He gives tons of examples of how you could learn from everything from new materials to For example, we've heard of things like Southwest Airlines using how ants do foraging to create a more effective way of them to have people get onto the airplane and get off the airplane. So there's tons of such examples that he talked about in class. So we looked at this design process earlier on. So what we're trying to do now is mapping onto this this sort of biomimicry or biomimetic design process. So distill your functions. So each of the students has to come up with a list of functions that they want their product to perform. So things like, my product needs to fold, it needs to display information, it needs to be light, it needs to be packed away, it needs to, whatever it might be, from these from four disciplinary perspectives. We come up with a list of functions. Then they look at nature and see if there's anything in nature that might do these things well. I think it was the Sunday's New York Times has a large article on how there's a ton of adhesives, natural adhesives that work underwater that these mollusks and other things have come up with. But we have a really hard time as engineers coming up with good adhesives that work underwater. And a lot of the adhesives we have tend to be pretty toxic, things like epoxy. So how does nature do it? And can we learn from that process? To mimic that. We also do this other thing called application of life's principles, and I'll get to that in just a second. So the Biomimicry Institute has this project called Ask Nature, and this was actually sponsored by Autodesk. So Autodesk worked with IDEO, the design firm in California, and the Biomimicry Institute to come up with this website called asknature.org. And I urge all of you, when you get a moment, to check out this website. What it does is you can see this question, how would a butterfly inspire your next design? What they've done is they've listed a whole range of organisms, plants, animals, etc. And they've looked at how, for example, the butterflies, there's this company called Qualcomm that now has displays on their cell phones that are inspired by butterfly coloration. So butterflies, the way the Morpho butterfly, for example, has this brilliant iridescent blue on its surface. It does not use any toxic chemicals. What it does is it uses the right kind of refraction on its scales to create that color. So they've tried to use that in the design of the display. So there are certain things in nature that we can look at and maybe come up with more sustainable solutions. So you can go to this website, you can type in something that says, I need folding, I need adhesion, I need blah, 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 and it'll give you a list of organisms in nature that has solved that problem. So what Janine says is that what we see around us in the world is billions of years of nature solving problems. And what failed is essentially a fossil. So we can learn from what exists around us. And that's one of the things we're trying to use as a technique to try and come up with creative ideas, but also more sustainable ideas. So that's one thing. The other thing we do is we use this thing called life's principles, also developed by the Institute. So in cases where you can't really find an organism to inspire design, maybe we can look at some of its basic principles. So what are some of the principles? I know it's a little hard to see, but life creates conditions that are conducive to life, to extend life further on. Life adapts and evolves. Life is resilient. So there are a series of these principles, and we try to have students look at those principles as well as while they're designing. So for instance, once the students come up with a list of functions, for example, the industrial designer says, I want something that's easy to clean harmlessly. Well, how would organisms do that? Well, the lotus leaf has a mechanism by which water rolls off its surface and takes the dirt with it. And now there's actually a lotus paint that does exactly that. You can put it on buildings and it self-cleans the building. So they look at these sort of functions and then come up with their solutions. We also have to look at things like this. When you look at nature, what does a dung beetle do? Well, nature produces a ton of waste. It's just that it's not toxic and it actually is usable. So somebody else can find some use to it. And there's this industrial park in Kalundborg, Sweden, where they're trying to use this idea of industrial symbiosis, where the raw material, say hot water that comes out from one plant can be used as raw material for something else. So as the business students are thinking of the supply chain, they try to think of these sorts of ideas, at least conceptually, in their plans. Another quick example before I wrap it up was one of the student teams was working on a project where they were trying to, the context was the Navajo reservation. How do you access water? Access to water can be sometimes difficult in these locations. So there are these plug-in devices that you can plug into the air and it plug into the wall, and it captures moisture from the air and makes it available for drinking. So they were trying to do that. They wanted to have it available off the grid, because in some cases you don't have access to electricity on the reservation. So they looked at this beetle. It's called the Namib beetle. It exists in Africa. And what it does is it has on this, you can see those little bumps on its back. It has these hydrophobic and hydrophilic surfaces on its body. So it attracts water from the fog that rolls in certain times of the day in this desert, in the mid-desert. It attracts the water. As the droplet builds up, it rolls down the hydrophilic surface, and it's right into its waiting mouth. So that's how it drinks water. So they tried to use this technique for a product they were designing. So they designed these panels with these hydrophobic and hydrophilic surfaces that collects the water, has a filter underneath, and it makes it available for drinking. So these are just some techniques by which we are trying to use the notion of biology in the classroom, and where we think that if we try to create some sort of a love affair between design and biology, we might be able to come up with some more sustainable ideas for the future. So it's an experiment that we're doing right now. This is our second year of doing it, and we hope to come up with more interesting ideas. And Luke in the back is actually working on it right now, so if you have any questions for him, he'd be happy to tell you how he's using biomimicry in something that he's working on. So, thank you.